Hello friends, welcome to Learner's Planet. So this is our sixth theory session for the topic Is Matter Around Us Pure? In this session we are going to discuss about the changes, the different types of changes. Say in science we can say that there are two types of changes, the physical change and the chemical change. Either there will be change in the shape, size or appearance of a substance, or there will be change in the composition of a substance. There is a chemical composition of a substance. So change can be either a physical change or a chemical change. In this session, we are going to discuss about the physical and the chemical changes. Physical change. What is a physical change? You would have studied this in your previous classes. It is a change in the physical state of matter under suitable conditions. A change in the physical state of matter or a change in the physical properties of matter, like shape, size, color, appearance, state, right? So a change in which the shape, size, appearance or state of a substance may alter, but its chemical composition remains the same, is what is a physical change. Say if you tear paper, what will happen? The paper will be broken into small pieces, or an intact paper will be changed into the pieces. It's just shape and size has been changed, right? Say a cricket ball, when the players play it, say after some time, what happens? The color of the cricket ball changes. Because of the dust, because of the mud over there, the color changes. That is the physical change. Fine. Say if you break an egg, what happens? The inner content spills out. That is a physical change. So whenever there is a change in the shape, size, appearance or state of a substance, it is called as a physical change. There is no change in the chemical composition, it remains the same. Second, take a log of wood and break it into pieces. This is a physical change, right? So a physical change occurs when there is change in the interparticle spaces and also the interparticle forces. Let's take the example of water. Right? Now water exists in all the three states of matter. That is the solid, liquid and gas. In solid state, if I say solid, liquid and gas. In solid, what happens? The particles are closely packed. Right? The interparticle space means the space between the two particles, is very, very less. Rather, they are closely compact. Whereas in liquids, the interparticle space is more. In gases, the particles are far off from each other. Right? Now, there are some forces of attraction between these particles. This force of attraction is maximum in case of solids. It is less than solid in case of liquids, and in gases it is negligible. The force of attraction is very, very less. Where the force of attraction? Between the particles of gases. So when these changes take place, say water, it can, on freezing it changes to ice. Or water, on boiling it changes to vapor. So what is happening there? The interparticle spaces are changing. See, these are ice crystals. These are solids, right? The particles are compactly spaced. When it melts, it changes to the liquid state. The particles are far off. Now when water is boiled, it will change to gaseous state. So what is the difference between these three states? Between solid, liquid and gaseous state, that is gaseous state of water, that is ice, liquid and vapor. It's just that ice being solid, the particles are close to each other. The force of attraction between these particles is very high. In liquids, the particles are far off. The force of attraction between the particles as compared to ice is less. And in vapor, the particles are very far. So how this physical change has occurred? This physical change has occurred due to the changes in interparticle space, that is the space between the particles, and the interparticle forces of attraction, that is the force of attraction between the particles. When the particles are very closely spaced, very closely placed, compactly arranged, the force of attraction is very high. And the force of attraction is very high. The particle is in solid state. Whereas when the particles are moving, they are at a distance, the force of attraction is less and they change to the liquid state. And in the vapor or the gaseous phase, the particles are very far from each other and the force of attraction is very, very less. So the physical change occurs due to the change in interparticle spacing and the interparticle force of attraction. This is in case of the liquids, or in case of the things which exist in all three forms of matter. Sorry, all the three states of matter. The characteristics associated with the physical change. There is no change in the composition of the substances during the physical change. Say water, when it was in the solid state, that is ice, liquid and gas, that is the vapor. The composition of water is not changed. It is H2O in ice form also, H2O in liquid form also, and H2O in gaseous state also. It is not chemically changed. It's not that in ice it is H2O4, in liquid it is H2O, and in gaseous state it is H4O7. No, this has not been done. The chemical composition is not at all changed. What is changed is just the state of matter. Now the another point is, no new substance is formed during a physical change. Obviously, no new substance is formed. If I am tearing paper into pieces, no new substance is formed. If I have broken an intact pen, no new substance is formed. If I am cutting a log into pieces, no new substance is formed. Right? So, none of the new substances forms. It's just that the shape, size and appearance change. That's it. And the state changes. The change is temporary and can be reversed by reversing conditions which bring about the change. Say in case of this, water is liquid. If I am increasing the temperature, if I am heating water, it will be changed to vapor state. That is a gaseous state. Now when this vapor state, it is cooled, it will again change to liquid state. When this liquid state is cooled or frozen, it changes to gaseous state, it's solid state, sorry. That is, it changes to ice. So, when the changes in which states of matter is changed, or the changes in which a substance when changes in the states of matter, when the state of matter is changed, then the changes can be reversed by changing the conditions. Right? Now, in this, no energy change occurs during a physical change. Here, in this state is not changed, no energy change occurs. Fine. While tearing paper, there is no energy change of the paper. So these are the characteristics associated with physical change. Let's take a few examples of physical change. Say a goldsmith uses a piece of gold to make variety of ornaments. That is a physical change. The properties of gold are not changed. Gold can be molded into a coin, it can be molded into any form of jewelry, a ring or a chain or anything. But Does it change the property of gold? No. The chemical property of the gold is not changed. It's just the shape and size of the gold is changed. Another common example is water, right? So, in a physical change, the chemical composition of the substance is not affected and no new substance is formed. Let's take a few more examples. It is dissolution of sugar in water, or dissolving of sugar in water. When sugar is dissolved in water, it seems to disappear completely, and not even a very powerful microscope can show us the molecules of sugar in water. Say when sugar is dissolved in water, it forms a homogeneous solution. The particles of the sugar are not at all visible, right? The solution obtained is evenly sweet. That is, every part of the solution is evenly sweet. It is not that a part of solution is more sweet and the other is not. The other is less sweet. And also, sugar can be obtained from sugar solution by evaporating water. That is, by boiling water. By boiling this solution or by heating this solution, water will be evaporated and you'll get back the sugar. So, dissolution of sugar in water is what change? Physical change. Another example is magnetizing an iron rod. Say, and this is an iron rod. It can be converted into a magnet by passing an electric current through insulated coil wound around it. If there is a coil wounded around it, and if a current is passed through this coil, this particular iron bar can be magnetized. That is, this iron bar can be changed to a magnet and it will have a magnet-like property. What is the property of magnets? The property of magnets is to attract the iron objects towards it. So this particular magnet will now have the North Pole and the South Pole. Say if the current is passed through the coil wounded round an iron bar, the iron bar can be magnetized. Now the iron bar obtained will have a North Pole and a South Pole. Right? So this will have the properties of magnet. Now if the direction of current is reversed, the North Pole changes to South Pole and the South Pole changes to North Pole. Once this North and South poles are formed, now if the direction of the current in this coil is reversed, the poles also change. But in this case, students, what has happened? Iron has acquired the magnetic properties. That is, it will attract the objects made up of iron, nickel. But the property of iron is not changed. The chemical composition of iron is not changed. It still contains the atoms of iron. It's just that this iron bar has been magnetized. It will behave as a magnet, but chemically it's not that now say iron bar has got Fe atoms and magnetized iron bar has got some FeO atoms. It doesn't happen. So the chemical composition is not changed. It's just the physical property has changed. That is, that iron bar has now become a magnet, or that iron bar has now been magnetized. Glowing of an electric bulb. Say when the electric current is passed through the filament of the bulb, the filament starts glowing. When the current is stopped, the filament stops glowing. That's it. So with the flow of the current, the filament of the bulb glows, and when the flow of the current is stopped, the bulb stops glowing. So this is also a physical change, right? So I can just say that a physical change is a change in shape, size, appearance of a substance. There is no chemical change, that is the composition of the substance remains the same, right? No new substances formed. I hope you have understood this physical change. Now let's take up the chemical change. Chemical change. What is it? A change in which the chemical composition of a substance is altered is called a chemical change. Right? So when the chemical composition of a substance is altered, it is called as a chemical change. The substances combine with each other, producing a new substance with properties different from the combining components. Say for example, I have taken this example like hydrogen combines with chlorine, producing hydrogen chloride. That is, hydrogen gas combines with chlorine gas, producing hydrogen chloride gas. That is in the presence of sunlight. Right? Hydrogen, when it is treated with oxygen, it produces water. So here what is happening? A new substance is formed. There is change in the chemical composition. There is change in the property. Say hydrogen is a gas, chlorine is a gas. Now HCl is also a gas, but it has got the properties altogether different from hydrogen and chlorine. Likewise here also, hydrogen is a gas, oxygen is a gas, and water is a liquid. Hydrogen gas is combustible, oxygen gas supports combustion, but water, it doesn't support combustion. So in a chemical change, what happens? The substances, they combine and they produce a new substance with entirely different set of properties. Right? Now the characteristics associated with chemical change. A new substance is formed as a result of chemical change. There is always a change in composition of the substances undergoing chemical change. So the composition changes. The chemical change is of permanent nature and cannot be easily reversed. Remember here, the components, they are reacting with each other. They are combining with each other. So in this case, the change cannot be reversed. Say there are most of the reactions like hydrogen combines with iodine, producing hydrogen iodide, and this hydrogen iodide reverses back to hydrogen and iodine. There are many changes which can be reversed, but most of the chemical changes cannot be reversed. Right? Energy changes always occur in chemical reactions responsible for these changes. So there are energy changes. Energy is absorbed for the formation of a new compound. Right? Now let's take a few examples. See here. When wood is burnt, chemical change takes place. The composition of wood changes. Say wood, it is composed of large amount of organic compounds there. Right? When it is burnt, it changes into ashes. It is no more the log of wood. Right? So it changes into ashes. So what happens when wood is burnt? Chemical changes take place. So burning of wood is what? It's a chemical change. Log of wood is burnt. The chemical composition of the wood changes. So burning of a wood is a chemical change. Now let's take up the next example. The cooking. Cooking brings chemical change in the substance. How? These are French fries. These are made from potatoes, right? So if you take an intact potato, what is there? There is a lot of carbohydrate or starch in this. When it is fried, it is deep fried, the chemical composition of the potato changes. So you can eat French fries, but you can't eat a raw potato. Can you eat potato? No. But if it is cooked, if it is changed into French fries, you can eat it. So likewise, cooking brings a chemical change. Cooking of rice, cooking of wheat, of anything. Cooking causes the change in the chemical composition of the substance. Whatever is being cooked. Right? And for that matter, say a chapati cannot be changed into dough. That is a chemical change. French fries cannot be changed into potato back. It is a chemical change. So chemical changes are irreversible. right? See, there's a rusted bolt. A layer of reddish brown substance called rust is formed on the iron objects. You must have seen this. This is also a chemical change because iron surface is there, the iron atoms are there, right? But in this rust, a new compound is formed. Now the compound is Fe2O3, it is XH2O. So this is the rusted bolt and this new compound is formed. So rusting of iron is a chemical change. Right? Say this rusted part, this falls off as a brown powder. So rusting of iron is a chemical change. This is another example of a chemical change, students. Iron is a grayish-white metal and conducts electricity. Right? Being a metal, it conducts electricity. It is attracted by a magnet. Of course, yes, you all know this. And reacts with dilute acids to yield hydrogen. Iron reacts with dilute acids. You don't need to remember these reactions. And forms what? Here the products formed will be iron chloride, that is ferric chloride, and hydrogen will be released. Okay? It is twice. Likewise, sulfur. Sulfur is a non-metal and is yellow in color. It dissolves in carbon disulfide. So, iron is a metal. It conducts electricity. It is attracted by magnet and it reacts with dilute acids to yield hydrogen. Whereas sulfur is a non-metal, is yellow in color and dissolves in carbon disulfide. When powdered iron and sulfur are heated together, a completely new substance, that is iron sulfide, is formed. That is iron and sulfur. They are heated. A new substance is formed, that is iron sulfide. The properties of iron sulfide are entirely different from those of iron and sulfur. Say, iron sulfide doesn't conduct electricity. It is not attracted by a magnet. It doesn't dissolve in carbon disulfide. Right? So, iron sulfide is black in color. It is not attracted by a magnet, does not allow electric current to pass through it. And it reacts with dilute acids to form hydrogen sulfide gas. That is, FeS dissolves in dilute acids and it forms hydrogen sulfide gas. Right? So, ferrous sulfide or iron sulfide dissolves in hydrogen chloride, right? I'll make it 6HCl, I'll make it twice of FeS, I'll make it twice of FeCl3 and H2S. Okay? So, it is thrice of it. There is no need to balance the reaction. We'll be doing balancing later in our next sessions or in our next chapters. So it's just that you remember that the iron sulfide reacts with HCl forming iron chloride or ferric chloride and H2S gas. Whereas iron reacts with dilute acids and gives out what? Hydrogen gas. So the property is different. In short, the properties of neither iron nor sulfur are exhibited by iron sulfide. So in a chemical change, the chemical processes, the chemical reaction takes place and a new substance is formed whose property is different from the reacting components. Right? So this is about the chemical change. So this is how the physical and the chemical change takes place. So students, there are certain reactions or certain processes where both physical and chemical change take place. Say if I'm eating a chocolate, right? I'll chew it first and then I'll digest it. So chewing of a chocolate, what it will do? Chewing of chocolate. The chocolate will break down into pieces, so it will undergo a physical change. Then digestion of chocolate. The components of the chocolate will be acted upon by saliva. The new products will be formed. The sugar present in it will be dissolved. So digestion is a chemical change. Right? So there are processes, more processes where the physical and the chemical change take place together. Say, let's take a few more examples. Conversion of milk to curd. What is it? It is a chemical change. Right? The chemical change has taken place. See, in the milk there is lactose present. And in the curd, lactic acid is present. Rusting of iron nails is a chemical change. Burning of magnesium ribbon. Magnesium ribbon. What is it? In air. It is of course a chemical change. Magnesium combines with oxygen present in the air and forms magnesium oxide. So it's a chemical change. Burning of coal. What is it? Burning of coal. Quickly tell me, what is it? It is a chemical change. Because on burning, the composition of the coal changes. Likewise, dissolving of salt in water. What type of change is it? It is a physical change because no new substance is formed. Crystallization of copper sulfate, that is copper sulfate changing into crystals. Crystallization of copper sulfate. It is a physical change because see, the formula of copper sulfate is CuSO4. On crystallization, the formula remains the same, the composition remains the same. It just acquires water molecules. That's it. Right? So crystallization of copper sulfate, it is a physical change. Right? So this is all about the physical and the chemical change, students. And this is all about this session. Now I'll be concluding this session, and in the next session we are going to discuss about the separation of components of mixture. The methods of separation for the separation of components of mixtures. I hope you have understood the physical and the chemical changes. Just look around yourself, you'll find so many changes occurring, and try to identify the type of the change. Thank you, students. Thank you for being with me. Thank you for listening patiently, and do have a nice time ahead.